Hey, what's going on, guys? In this video we are going to see how to prove this one using well-ordering property. Here the proposition says let S belongs to a subset of natural numbers. Let A is equal to x belongs to real numbers. 1 over x belongs to set. If S is not an empty set, then A has the largest element. Okay, now let's see how to prove this one. First, they have mentioned S is not an empty set. Let's put that one first. Assume S is not an empty set. Since S is not an empty set and this is bounded below by 0 because this is a natural number, so let's state that one. Since S is non-empty and bounded below by 0, if these two conditions satisfied, then by well-ordering property is one of the axiom. I put the link of the video I created with the axioms in the description, so you can go ahead and see that. Well-ordering property says that when we have a non-empty set and bounded below by 0, there exists a minimum element. So we are going to say it's actually smallest element by the ordering property. S has a smallest element. Okay, now here what we are going to do is we are going to introduce a smallest element, and we are going to say that's n, and it's going to like n. If n is the smallest element, it has to be from the S, right? Because we are saying S has a smallest element, so we are going to introduce n and say this belongs to the S. Now let's go ahead and mention that choose n belongs to set to be the smallest element of S, to be the smallest element of S. Now what we are going to do is we are going to put A is equal to 1 over n, and we claim that A is the largest element of A, because if you divide anything 1 by smallest element, that's going to become large. Let's go ahead and put that. Put A is equal to 1 over n, and we claim that A is the largest element of A. A is the largest element of A. Okay, of actually capital A, because that's the one we have. Now we know that 1 over A is equal to n, because A is equal to 1 over n, then 1 over A is equal to n, and also 1 over A belongs to the S, so let's mention that one. So A belongs to A and X also belongs to A. Let's mention all of these things. I use a different color. Indeed, since 1 over A is equal to n, we have 1 over A belongs to S, and hence A belongs to A. Now let X belongs to A, then 1 over X belongs to S, and so n is less than or equal to 1 over X. Okay, let's continue here. I delete all of these things. Now the next thing is n is less than or equal to 1 over X. Therefore we can say therefore 1 over X also belongs to set S, and so n is the, because n is the smallest element, n has to be less than or equal to 1 over x. Okay, and if we rearrange this one, we can get, therefore let's put another one, therefore if we rearrange this one, x is going to become equal to less than or equal to 1 over n. Okay, I just rearrange this one, 1 over n, since n is also greater than 0, natural number, and then and x also greater than 0. In other words, we can say that x is less than or equal to a, because we said a is equal to 1 over n, right? A is equal to 1 over n if you are rearrange this one. So we can say x is less than or equal to a. Now finally we can mention that therefore for all x belongs to a, x is less than or equal to a, thus a is the largest element of S. A is the largest element of S. And finally we are going to mention that therefore if S is not an empty set, then A has the largest element. A has a largest element. Okay, that's it. This is our proof. The proof, like here we had to prove that then after the one that comes then, if it's if then statement, we use the first one and prove this is our claim. A has the largest element of largest element. We prove that A has the largest element here. Okay, I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.